Expedition 17 kicks off a new era for the International Space Station. Commander Sergei Volkov and flight engineer Oleg Kononenko are the first crew to start their tour on a station outfitted with hardware from all of the partner space agencies. And they'll finish up preparing the station to accommodate a permanent crew of 6. The commander has a couple of favorite activities in mind for the 6 months in between.
I'm looking forward to the relocation of Soyuz, because for me as a pilot, it's very interesting to do manual relocation, and we are going to relocate from a docking compartment to the FGB major port, and of course EVA. It's probably two most exciting things that I expect.
The Soyuz relocation is slated for early May. On the Russian spacewalk in late June, Volkov and Kononenko float outside in Russian spacesuits to upgrade the Strela, the Russian cargo crane attached to the Pirs module.
It enables us to move for a rather long distance without having to translate hand over hand on handrails. So on this boom, we are going to install a piece of hardware that's analogous to the US APFR, the foot anchor for the cosmonauts.
The cosmonauts plan to install a new exposure experiment and conduct 2 surveys. In the first, they scout locations on piers for later installation of a Kurs docking system antenna. In the other, they assess sites for a new operating base for Canadarm2.
We'll check the surface of the place we are going to be installed a PGF. It's adapter for the robotic arm. And it will allow us in future use the robotic arm on the Russian side. And in case we are going to reinstall maybe our docking compartment or use for another stuff.
But before all that, Volkov and Kononenko and flight engineer Garrett Reisman focus on preparing for arrival of the station's largest single module. The Japanese experiment module, the 35,000-pound, 37-foot-long centerpiece of the Japan Aerospace Exploration Agency's laboratory complex, Kibo, which means hope, arrives on STS-124. It's so heavy itself that much of its equipment was sent on ahead inside the logistics module delivered on STS-123. And the station crew has got to get all that gear ready to move.
And basically, we're the caretakers of all this equipment, and we have to prep all that equipment so that when the main laboratory shows up, it's all ready to be installed.
Arriving along with the Japanese lab is flight engineer Greg Shamatov, who will be one of the robotics operators relocating the Japanese logistics module onto the new lab after it's installed on the port side of the Harmony node. His tour of duty will focus on setting up Kibo and all of its components.
It also has an airlock and a robotics arm as part of it. And about a year later, they'll be bringing up an external platform, which will be the most capable facility we'll have on station for doing science outside of the space station, exposure to the vacuum and radiation space environment.
After Reisman goes home with the STS-124 crew, Expedition 17 will concentrate on working with the Japanese Control Center near Tokyo to commission Kibo.
There's checking out a lot of the systems, there's tests they want to do, make sure everything's working right. There's the science modules, installing those and configuring those to actually start doing science and testing them out.
They'll also relocate several large rack facilities into the new lab modules. 2 express racks, 2 zero-G stowage racks, and the laboratory freezer move from Destiny to Kibo, and the 2 human research facility racks move from Destiny into Columbus. The moves clear space for the hardware that's needed to expand the station's crew complement to 6.
So there's water reclamation racks, there's hygiene racks, there's new sleep stations, there's various different facilities that we need and a lot of equipment and supplies that are needed to support, for example, emergency equipment for more people and so on.
All that gear will be delivered on the shuttle mission due at the station just after Volkov and Kononenko go home in late October, and will get the station ready to host larger crews starting in early 2009.
Now we can use all this knowledge of previous years of space exploration, and we were actually able to do this. We built the station, we continuously use the station, we doing experiments, and we're working together.
This mission on the International Space Station is the first trip to space for each of the Expedition 17 crew members, but a trip that each of them has had his sights set on since childhood. Russian Air Force Lieutenant Colonel Sergei Volkov was born in the Kharkov region of Ukraine. He was 3 when his family moved to a small Moscow area town for his father's new job.
It's only 14 big houses, and everybody knows each other. You know, it's like a small village. And I felt that somehow everybody wants to help me.
The place was Star City, and the job was cosmonaut. Alexander Volkov spent more than a year in space on 3 flights in the late 1980s and early 90s. For his children, who never knew anything different, Star City was just home, and the people, just the neighbors.
And first time that I realized that my father is really very famous person when I visited pioneer camp during the summertime. And people around me were really excited and curious about myself personally and my father. Actually, after that, I realized, okay, probably to be a cosmonaut is not just a job, it's something more.
But a job he wanted for himself.
From my side, I grew up in this environment. I know everybody who was involved, actually, who were involved in space program, Russian space program or international space program at that period of time. And I think it's one of the moments that pushed me. It's the influence of these people.
Volkov entered the Tambov Air Force Pilot School after high school and flew as a cargo pilot in the Air Force for 2 years before being selected as a cosmonaut candidate in 1997. This mission makes him the world's first second-generation space traveler. Oleg Kononenko was born in Charjo in the Central Asian country of Turkmenistan, where his father was stationed with the Soviet military.
It's surrounded by a desert, you know, and it had different kind of architecture. At that time, they were basically clay houses. There weren't that many brick houses. They were mostly one-story buildings. So this was kind of a common landscape for me.
Although his surroundings were stark, the young boy had a bright future for himself in mind.
I was born after the first Sputnik flight, after Gagarin's flight. But as far back as I remember myself, I always wanted to become a cosmonaut. After I graduated from high school, I made a conscious decision to go to the Aviation Institute, and I wanted to become a cosmonaut.
Kononenko took the engineering route rather than the pilot path to becoming a cosmonaut. He earned a degree in mechanical engineering at the Kharkov Aviation Institute, was qualified as a patent specialist and inventor, and pursued research projects in aircraft engine design. Near the end of his college career, he entered an engineering competition in Moscow.
There is a panel that's called Tsiolkovsky's Readings in Moscow, so I brought my research there, and I got the 2nd place. I got my diploma from Mr. Kozlov, who was the chief designer of the construction facility and the design facility in Samara. So we fell to talking together, and he invited me to work in Samara.
In 1988, Kononenko went to work at the Russian Space Agency's Central Design Bureau in Samara. In just 6 years, he became chief designer, and 2 years later was selected as one of its cosmonaut candidates. After basic training in Star City, Kononenko was assigned to the Cosmonaut Corps of the Rocket Space Corporation Energia, where he began training for international space station missions.
It is going to be a continuing process of learning new things, gaining new knowledge, new information, and it's certainly worth it. Without that, mankind will never develop.